So thanks PhD Chamber of Commerce and thanks to Mr. Anil Chaudhary who gave me the opportunity to present our company like KJSS Cosmos, which is a startup company. We set up this company in the month of December 23 after I left the job at SR and started my own business. And we have developed many products and the major aim is the digitalization of the steel industry. With that aim, we set up this company. So basically, by looking at this QR link, you can download our main corporate presentation. And with this link, you can find out the presenter information about me. Basically, in this presentation, I'm going to cover the complete techno-commercial comparative of the different steel making process, specifically covering about coal-based DRI, because that's the thing which I found it was missing in this, and how to do the CO2 calculations, like how much CO2 we are producing through different steel making processes, and capturing the CO2, utilizing the CO2 within the steel plant itself, and what are those plants where this is being done. So this is just in brief about our products. These are the unique products developed by KJSS. First is PROCA, Procurement Assistance, which can reduce the ordering time of the steel plant equipment and capex equipment, large equipment, and the MRO items to it can reduce by 80%. The actual time which we take, say 10 months, that will be reduced to 2 months. All technical comparison, commercial comparison is being done through artificial intelligence, and the system is giving the rating. So detailed presentation you can find on this link. You can go through that. Our product is plant on cloud. Basically, we have taken all the data of the plant, ERP system, and the other areas on the cloud, and then for a particular person, whatever information he is needed on the real-time basis can be given to on his mobile. And we are making its presentation to JSPL on this Monday and with on a live data. We have set up a small engineering company also, which is taking care of right now cold rolling mills and the processing line engineering. And another technology which we are working is for coal-based DRI, sponge iron producer through coal-based DRI. They are cooling the sponge iron with the water. So we are suggesting a technology where if they are cooling 1 ton per hour of sponge, they will get in return 0.5 ton of steam and high saturated steam. So if we do the sponge iron dry cooling. So the complete presentation is there on that link. And another solid waste management system. This was invented by me, and it's on the patent. We got the patent also, and the detailed presentation as well as animation you can see on those links. And you can have this presentation later on. So what I think is until and unless we calculate how much we are producing, how much CO2 through which process is coming up, till the time we can't say that we are controlling the things. So considering this, I'm just explaining in brief how to do the CO2 calculation, how much CO2 is being produced through which route, and what is the primary factor of it. This we are discussing right now about scope 1. Basic thumb rule is that if we are utilizing 1 unit of carbon, then we are producing approximately 3.67 unit of CO2. So the detailed calculations we have made with all numbers, in the coal-based DRI, to produce the sponge iron, we are generating around 2 ton of CO2. Similarly, if we use the blast furnace, then this CO2 generation is around 1.8 ton for making the crude steel. And similarly, if as in case of JSPL, we are using syngas based DRI system that is producing around 1.4 ton of CO2. Natural gas based DRI is producing around 0.87 ton of CO2. That's the number which gives a fair idea which process is producing how much CO2, and the complete calculation is explained here. In case if anybody has any query with respect to the calculation part, he can connect me anytime. And this is the scope 2. Basically, scope 1 is with respect to the fossil fuel consumption. Scope 2 is with respect to the power what we are utilizing. Like if we are using 1 unit, we are producing around 720 gram of CO2 by using 1 unit of electricity. And this number is like 370 grams in case of USA. So the difference there, like in case of USA, the power what they are producing is mainly through like nuclear power and others. So the CO2 generation is much lesser. So whatever we do, like if we want to compare with ourselves with the Americans or European or big Chinese partner, because their CO2 generation through power is much lesser than us. So here, like I have briefed about how much is the estimated unit consumption process-wise and how much CO2 we are producing through which process, so that we can have a specific calculation for our own plant, like how much CO2 I am generating in that. If I am utilizing like pellet plant, sinter plant, coal-based DRI, blast furnace, whatever the modules we are using, just add those numbers. Then you will get a number how much CO2 is being produced through scope 2. And basically the overall CO2 production in any of the plant is sum of scope 1 plus scope 2 plus scope 3. Scope 3 is mainly on the transportation part. Like for producing like say 1 ton of steel, I need to import say around 3 times of the raw material. So that raw material coming in the plant and selling the product, how much fuel consumption has happened. So that's also adding to the CO2. So basically, as an international thumb rule, is we are taking 0.3 kg per ton. So whatever we do, in whatever process we go, in no process the CO2 production is less than 3 ton in India, if we add scope 1, scope 2 and scope 3. So what we are suggesting here, like we should concentrate on the carbon capture unit. I will explain the reason why, because like once we will discuss about the capex and opex of the different process, then the other processes like other than coal-based DRI and blast furnace, other processes are not very much economically viable. So nobody is going to pay, like if I am buying a steel, I'm not going to pay 1 rupee extra for like it's a less carbon production in that process. So that's the reason like we suggest that after the ESP, it's the complete route shown for the coal-based DRI system. After the ESP, if we do the carbon capture and feed it into the CO2 grid, like we are making the grid in the plant for like gas, all kind of gases and this, we should have a CO2 grid also in the plant. That's the suggestion we are making. And CO2 capturing is not a big deal. Like at present, there are like amine-based solution technology being used in Tata, being used in JSPL. But what are we doing like after capturing those CO2? We are emitting to the environment again. In none of the plant, like we are utilizing this CO2 to either in the steel plant or liquefying it or producing the product, what mentioned by Mr. Chaudhary, that CO2 is a raw material for that, like the products which they are using. So there is a good possibility to utilize the CO2, so capture it, liquefy it and utilize it. Similarly, like there are the other technologies from China, like pressure swing absorption and others. For that, we also have some tie-up with some universities in China. And there they are doing a lot of experiments on utilizing the steel CO2 within the steel plant itself. That also we will explain. So like in the China, basically 3-4 plants like Jingtang, they have a 300-ton BOF, Jiaquan Steel, Shougang and others. They are utilized, they are doing a lot of experiments on utilizing the CO2 within the steel plant. So basically, here I will be presenting their results and their problems what they are facing, and we suggest that the steel industry should come together and do this kind of experiment and develop their own technology before we need to buy commercially from China. So major advantage of this CO2 capturing is utilizing the CO2 within the steel plant is 50% CO2 reduction, and dust generation is reduced by 15%, dephosphorization is improved by 7 to 14%, and there is a energy saving also. So as time is limited, I am running faster. So this is basically the results of the CO2 what they are utilizing in the steel plant, how their results are coming. All this data was collected from the universities which we had tied up for utilizing this CO2, capturing the CO2 and utilizing in the steel plant. And this just I'm sharing capex and opex, like CO2 production cost, capturing cost is coming around $14.5 per ton of CO2, and capital cost, like if we need to set up a plant of 29,000 nm³ per hour CO2 capturing system, that will cost around $9 million US. CO2 product will be around 3,500 nm³ per hour. Power consumption will be 3 megawatts. These are just capex and opex of CO2 capturing system if we go on a pressure swing absorption technology. This is the complete flow chart how this CO2 capturing happen through the flue gases. And basically it is going to be the future of steel industry, that all the processes we are going to capture the CO2. If we aim to be CO2 neutral or then there is no other way possible which at present I can see. Maybe in future we may get some other things, but this is the most viable solution I feel studying on different processes. So these are just the results of CO2 capturing. Here I am presenting different process. I have taken an assumption of if we want to set up 4 million ton integrated steel plant of producing hot rolled coil, then what will be the capex through different route, and what will be the operational cost on a different route. If we are putting up a 4 million ton plant based on coal gasification, DRI, SAF and BOF, then the capex will be around $2.5 billion and HR production will be around $500. So you can see in this process, the minimum capex is on the blast furnace and BOF route, which is around $1.8 billion as compared to capex on the coal gasification route. And hot rolled coil manufacturing cost, operational cost is $431, which is it's not including the interest and depreciation and all that part, or it's the pure operational cost. If we compare it with the CGP route, then it is coming around $513. So capex is lesser, opex is lesser, then why should the people should go for the process where if the government is not giving any benefits or there is no advantage of going on that, because entrepreneur will always think on the numbers which is more economical. So here I have put up all kind of processes and their capex as well as opex for information. In case of any query, you can contact me anytime. And this is the capex and opex based on coal-based DRI system. In the coal-based DRI, if we go with standard thing pellet plant, induction furnace and EF, or if we go with the coal gasification, in the case of if 1 million ton, I am spending $270 million. Through coal gasification route, if I go on DRI plant and electric arc furnace, my capex will be around $700 million. So there is a capex is high, opex is high, means by looking at this number, this doesn't make any sense we go on a new technology and put up the things and do the experiment. That's the reason, like Chaudhary sir said in the starting, why everybody is putting up the blast furnace. Why everybody is concentrating only on the coal-based DRI system? So that's the main reason. So by looking at all these things, there is a good sense like carbon capturing and utilizing within the steel plant or liquefying it. Within the steel plant, I have all the data of the different plants where they have used, what kind of problems they are facing, like because it's an endothermic reaction. So the refractory gets damaged very frequently. There is a mushrooming effect within the liquid bath. So these are the problems which they are encountering right now, the universities in China. So there are many ways to save energy and produce sponge iron, like I was mainly concentrating on coal-based DRI. Like the shell air fan, which they are using, shall be independently driven by VFD. And hot sponge iron being like exited from the rotary kiln, that's what which I mentioned in the early stage. Because if you're cooling with the water, you're wasting the heat in the water. So better is to utilize that heat. And its IRR is like return on investment is less than an year. So that's the showing the principle of induction melting. I think everybody knows about it. And these are the different induction furnace technology, like current control and voltage control, series and parallel. So whenever we are going for a precise kind of a thing, we should go with the voltage control, like in a foundry. But if you're producing the steel, then we should go with the current control. There are the pros and cons and benefits and advantages and disadvantages of different technologies. So sorry I covered it so fast, but in case if you have any query, you can write me anytime. And this presentation you can take. And like if I come directly on the first page, if you scan this QR code, you will get this presentation. And all the links will be available to you. And our products like plant on cloud, sponge iron cooling, Proca, these are the new products. These are not existing anywhere. And we need the support from industry that like we are a startup, we are investing hugely, whatever we earned throughout our 30 years of life into development of this product, that this gets some sort of a benefit to the steel industry and the other industry. Thanks a lot.
Thank you, sir.